Hello, welcome to today's class. Today we would be talking about the concept of Weber's industrial location and the Smith's concept of spatial margins of profitability. So let's first start with what is the Weber's concept for industrial location. So Weber basically focused his theory on the concept of least cost location. So it basically tried to explain that when we are trying to locate at any position, it is based on the least cost. I'm trying to minimize my cost at that location where I'm trying to establish the industry. So basically, before we try to understand this concept in further detail, let's first understand few of the terms. He talked about two types of raw material. First is the ubiquitous raw material. These are the raw materials that are found everywhere. The next is the fixed or localized raw material. Those are present at certain places. For example, thorium, uranium, radioactive materials. In case of ubiquitous, I can say water, air, oxygen. So these are found everywhere. Specific would be uranium or kind of similar materials. Okay. Now, besides these, when we are doing manufacturing, there are two kinds of processes that we further try to understand. So first is the gross raw material. Gross raw material is basically weight losing. So if the weight of raw material is more than the finished product, what is there? It's a kind of gross industry. While what is a pure industry? Or pure industry is basically where the weight of raw material and finished products are the same. The most common example of gross industry would be a kind of food processing industry, from where from milk I'm trying to generate butter. Okay, so milk, you have the raw material is more and the finished product is less, so it's a kind of weight losing industry. The next important thing Weber tried to explain in his model was the concept of material index. Now, before we understand the concept of material index, be very clear this is applied only to localized raw material. So material index is the ratio of weight of localized raw material divided by weight of the finished product. Okay, so in this case, if the raw material is more than finished product, my material index would be greater than 1. This is case A. The case B is raw material is less than finished product, so my material index would be less than 1. And the third case, raw material equals to finished product, so my material index would be equal to 1. So now what happens in this is, if in this case, where the raw material is more than finished product, I would be trying to place my industry close to the source of raw material. Here I will try to place my industry close to the finished product. Okay, and finally in this case, I would try to place my industry at any point on the line. So these were the basic concepts that Weber discussed before he started to explain the theory. Now, let's talk about certain assumptions in the Weber's model. So Weber basically assumed the concept of isotropic plane. He said, basically, transport cost is the function of distance. Then you have production cost that he is taking into account. And according to him, transport cost and production cost are the major determinants. Later on, he added the concept of labor cost, where he gave the concept of isotims and isodepends. We'll be discussing those later. So these were the basic assumptions that Weber tried to incorporate. Now, based on these assumptions, he gave various cases. So the first case here, he discussed was a two-case model where you have material index greater than 1, material index less than 1, and material index equal to 1. Okay, so this is basically the point would be close to the location of industry would be close to the raw material. Here, the location of industry would be close to the finished product because material index is 1. And here, the location of industry could be at any point in between the raw material and the finished product. Okay, so these were the three cases that he basically gave in the two-case model. Now, let's talk about the three-case models. To try to understand the three-case model, let's first take an example of one pure and another pure. So you have basically two raw materials, raw material 1, raw material 2, and the market. Okay. Now, if both of these raw materials are pure, what would happen here is, let me bring this example in. So here is what would happen. Now, since both of them are pure, I have 1 ton of material here and 1 ton of material here. So initially they are 1 ton. When they combine, they become 2 ton. So the volume or the weight of the finished product is 2 tons as compared to the raw material. So what would happen? So here is 1 ton weight, 1 ton weight, and this is 2 ton weight. So this would try to attract it towards the market. So my location would be closer to the market at an intermediate position. If I have one pure raw material and another raw material which is also pure. Now in the next case, what I am doing, I have one pure raw material and one gross raw material. So for pure raw material, it's the weight of finished product and the raw material is the same, but in gross, I am losing the weight. So for this raw material, I have the same weight. So it's immaterial, I locate it here because I am finding the same material near market also, but the weight is adding. Here the important point is weight is adding even for the pure raw material. Okay. The other is the gross raw material. So where I would try to locate? I would try to locate my industry closer to the gross raw material, and how close? So that depends. So in one case, if I have 10 kgs of raw material and that becomes 9 kg of finished product. Okay. In another case, I have 10 kg of raw material and that becomes 1 kg of finished product. So in the first case, since the weight loss is not that much for the finished product, okay, I would try to push it towards the market. But if the weight loss for the finished product is higher, that means rather than transporting 10 kilos, I have to transport only 1 kilo. So I'll try to locate it closer to this point. So this is an example with one pure and one gross. Now what is happening if I have one gross raw material and another raw material which is also gross? So I have two gross raw materials here. If the weight loss here is 10 to 9 and here is 10 to 1, I would try to locate my industry towards this point because the transportation cost would become less because 1 kilo is converting to 10 kilos is converting to 1 kilo. So I would try to locate it closer to this point. So I would be locating closer to the raw material which is losing more weight. So more weight losing raw material is there, my industry would be closer to that point. If both of the cases it's from 10 kgs to 5 kgs, what would happen? I would locate at any intermediate location between the market and the raw material. So these are the three cases. In the cases of three, where you have two raw materials and one market. So the first case is both of them are pure. The second is one is pure, one is gross. The third is both are gross. Now let's move on to ubiquitous. if both of these are ubiquitous, so both the raw materials can be found anywhere, my obvious location would be near the market, because these two raw materials would also be present near the market, so my location would be near the market. So if both of them are ubiquitous, either pure or gross. Okay. The next is, if one is ubiquitous and another is pure. So if one is ubiquitous, it can be found anywhere. So I'll try to push it near to the market. Okay. The second is pure. So the weight of raw material and the finished product is same. So it hardly matters whether I locate it here or here. So I would prefer to locate it to the near to the market itself, because I'll have to bear less of transport cost. So my location would be at this point. So this is the case, again, location at market for one ubiquitous and one pure raw material. This is the most challenging case. So you have one ubiquitous raw material and another raw material which is gross. Now what is happening? I have two raw materials here. So one is ubiquitous, so it can be found anywhere. So obviously I'll try to push it towards the market. The second is gross. So it depends on the weight loss. So now the industry should be anywhere between these 2 points, between the gross and the market, because ubiquitous will also be present on this region. Okay. So my obvious industry would be at somewhere between the gross and the market. So it would be somewhere in this region. Now what is important here to understand is, if the weight loss is more, okay, I try to push that industry towards the raw material source. If the weight loss is less, I'll push the industry towards the market. So that's the only difference in this case. So here we can understand the various types of combinations of the resources that would be used in, and the location of the industry where it would be placed. Now, Weber also gave the concept of split of location. What is a split of location? For example, I have woods or logs. From that, I am making pulp. And from pulp, I am making paper. Now, transporting woods and logs takes a lot of transportation costs because they are heavy. So I would try to put my pulp industry closer to the source of raw material. Close to raw material. So my pulp industry would be close to raw material. But the paper industry is totally based on consumption. Okay. So it would be close to the finished product of the market. So now paper industry would require this pulp, but it is driven by consumption, so it would be close to the market. So in this cases, there is a split of location. So the same process involves two industries, pulp industry and paper industry. But this pulp industry would be located close to the source of raw material. Okay, while the paper industry would be located close to the market. So this is what we understand about the split of location. Now there is another concept that we try to understand here, is the concept of isotims. So isotims is basically when I'm trying to move from raw material to market. Okay, the cost that is involved: 0, 5, 10, 15, and finally market, that is 20. So these are the isotims for raw material. Now I can have similar isotims for market. So from market, if I'm trying to supply the product back, what is happening is, this is 0, this would be 5, this would be 10, 15, and these would be 20. So these are the points where my transportation cost from the market is same, and these are the points where my transportation cost for the raw material is the same. So these are the isotims for raw material, and these are the isotims for the market. Now, what would happen if I try to unite the isotims for the market and the raw material? So let's try to understand the concept of isodipines here. So here is the concept of what is known as isodipine. So these R1, R2, R3 are the isotims for raw materials. So say if it is 5, 10, 15, 20, 25. Okay. Then those in the blue lines are the isotims for the finished products. So say these are 5, 10, 15, 20, and 20. Now what would happen is you have an intersection point. So where the isotim of 5 and 25 meet would be this point. Where the isotim of 10 and 20 meet would be this point. This is 15 and 15. This is 20 and 10. This is 25 and 5. So this would be the isodipine here. Okay. So this is what is known as the isodipine. Okay. So isodipines are the lines joining the same cost or the same total cost. So here I am including the concept of labor advantage. Isotims, on the other hand, involve cost of either the raw material or the finished product. Okay, and this involves both the raw material and the finished product. Now, let's try to do a simple exercise on this, on the concept of isodipine only. So I have bauxite, which is made from aluminium, and while processing it loses 60% of the weight. Okay, the distance between raw material and the market is 150 kilometers, and the cost of transportation is say $0.1 per kg per kilometer. What would be the isodipines for this if the entrepreneur is ready to pay $20? Okay, so in this case, since bauxite loses 60% of the weight, I'll calculate the material index first. So material index would be 100, that is the raw material, upon 100 minus 60% of the weight is lost, that's the finished product. So 100 by 40. So that's 2.5. Okay. Now what is happening here is, this is my material index. I'm moving from raw material to market, that is X, and market to raw material, that is Y. So if I try to solve this, I have 150 kilometers and my rate is $0.1 per kg per kilometer. So that's 15. So my first equation would be X plus Y is equal to 15. Now since my material cost is 2.5, my equation would be 2.5x plus y is equal to what the entrepreneur is ready to pay, that's 20. Now solving these two equations, I get the values of x and y. So the value of x is 3.3 and y is 11.67. Now I'll substitute these values. So this is the value of x and y I have got. Now I put the values of x. So supposedly I put x as 3. My value would for y would be 12.5. Here if I put 2, it would be 15. Here if I put 1.5, it would be 16.25, for example. Okay. Now I try to interpolate that on the graph. So if I draw a same graph, I have lines raw material and market. Okay. I have a line here. So this is 0, 1, 2, 3, 4, 5. Okay, and here it is 0, 1, 2, 3, 4, 5, and so on till 15, and the raw material here till 15. So I have the curves in this fashion. Okay, so this is my raw material curve for 1, 2, 3, 4. Okay, and I have the finished product curves here, starting from here for 1, 2, 3, 4, so on for 15, 14, 13. So I'll try to substitute and check these values. So wherever 3.3 is meeting with 11.6, that would be the first point on the graph. Okay, then I have 3 and 12.5. So this is the 3 line, and this is say line of 12. So this is my second point. I have 2 here, and this is the line of 15 that is crossing it. So this is my second point, and again it's the same point here. So what I'm trying to do is, this whole graph would be the isodepy. Now what is critical isodepy? So here T6 is the first isodepine, T7 is the second isodepine. I'll keep on drawing the isodepines till I reach a critical point beyond which I won't have any labor advantage. Okay, so that is what is critical isodepine. So in the same graph, if we try to understand in this fashion, these are the 3 critical isodepines. The region which is intersecting for these 3 critical isodepines would be the region of agglomeration. And what would be the region of agglomeration here? Agglomeration would mean, for example, I'm trying to bring in an industry which is manufacturing motorcycles. Okay, so I'll try to locate it near to the industry which provides screws, nuts, bolts, spare parts. Okay, so all these industries which I'm requiring would be located in this agglomeration zone. So the zone of agglomeration is the region where you try to maximize the economies of scale, and you have as much possible industries in that region. So your overall cost of production decreases. So this accounts for the concept of Weber's theory, which focuses on the least cost location based on transportation, production, and labor cost. Now, the Weber's theory holds true in present-day world because a lot of industrial locations are calculated or devised based on the concept of material index. It is a realistic concept that has been applied as compared to other theories, but still there is a lot of criticism that Weber's theory faces. First of all, the assumptions that it has taken into account, the concept of isotropic plane does not hold true. It's not always that transportation is a major element that does into the production function. So these are some of the major disadvantages of Weber's theory. Now we come on to the next theory, that is the theory of David-Smith. This concept is known as the spatial margins of profitability. Under this concept, what Smith tried to do was, he tried to interpolate the cost and the location. He said, for example, this is the line. Beyond this, since the cost of production is more, I'll incur loss. So these two in the blue are the loss. And this is the region I'll have profit, because in this region, my revenue or my income is more than my expenditure or my cost. So this is the region of profit. Since this is the region of profit, any industrial location for this plant between this region would be an optimal location. So he said this region would be the case of optimum location. And since it is a case of optimum location, we call the regions which is bounding this area as the margins of profitability, or we can say within this region, my industry would be profitable. So this was a very simple concept which talked about spatial margins of profitability, and which said that if I'm trying to say establish a plant which is manufacturing bicycles, okay, my plant which is manufacturing bicycle, if located between these two regions in this area, would be profitable, and beyond that, if I'm trying to locate that industry, it would not give me good returns. So that is what was the concept of Smith's theory. So in this class, we have talked about the Weber's concept and the Smith's concept. In the next session, we would be talking about the concept of trade and the comparative cost advantage in trade. Have a good day ahead.